Welcome everyone, and in this video I'm going to talk about isomerism in square planar complexes. And the first key thing I'm going to start with is the definition of a complex. Complexes are substances formed when transitional metals react with anions and some molecules. Now, these complexes have their own geometry and they form geometric isomers. Another thing that I'm going to define is a geometric isomer. Now, geometric isomer are compounds with the same molecular formula but different arrangement of atoms in space. But different arrangement of atoms in space. Now, from the definition of geometric isomer, we can now deduce that geometric isomers can exist in two different ways. And these ways include a cis and a trans isomers. You can have cis and trans geometric isomers. Now, the cis and trans geometric isomers also is exhibited by complexes. And I'm going to use a very easy example of a substance or more of a complex. And the complex I'm going to use here is a well-known complex. I'm going to use tetra aqua cobalt 2 chloride, which is written as CO Cl2 into bracket H2O 4. Now this one is an example of a complex. And I'm going to use this as my example to explain the cis and trans geometric isomer exhibited by complexes. The key thing I want us to focus on are the two chlorides found within that given complex. So I want to show you how this given substance can exhibit a geometric isomers of cis and trans. Now, I'm going to draw the structure of cis cobalt chloride bracket H2O, 4 of them. Then from that drawing, we are going to see what is what you can learn from it. Now, in my drawing, at the center, I'm going to have my cobalt at the center. Then, this cobalt is bonded to 4 water molecules. It is bonded to 4 water molecules. Because I want to explain the cis-ness. But there should be O here. Now to demonstrate cis, I must have the 2 chlorines bonded on the same side. In fact, let me use a different color to show that the 2 chlorines are bonded. I'm having chlorine and chlorine here. Now this is a demonstration of how a cis geometric isomer is exhibited by tetra aqua cobalt chloride as a cis geometric isomer. Now, using this example, how can we now define cis geometric isomers? Now, when exhibiting cis geometric isomer, we have to know that the reference point here are these 2 chlorines that are bonded. So when the 2 chlorines are found on the same side of the transitional metal, then we call it a cis isomer. It occurs when 2 similar atoms are found or are bonded, stop bonded on the same side of the transitional or the transition metal, will form a cis geometric isomer of that given element. So from there, we are going to have a cis tetra aqua cobalt 2 chloride. The tetranes are these. The first, this is our first water molecule, the second, the third, and the fourth. So bringing the tetranes, tetra means 4. Then tetra aqua cobalt 2 chloride as our example, in that case, to demonstrate cis geometric isomers exhibited by complexes. The next one that I want to explain is the exhibition of a trans geometric isomer by transitional metal complexes. Trans and I'm still going to use the same molecule. So the molecule in question here, the molecule in question is tetra aqua cobalt 2 chloride complex. I want to demonstrate the trans geometric isomerism exhibited by this molecule. Remember, it is still just the same molecule. Now I'm going to draw it. We are going to see how now the molecules are going to be displayed in space to show the trans isomerismness. Now I'm going to have my cobalt in the middle still, and that given cobalt must be bonded to 4 water molecules: H2O, 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 H2O. But now I want to put the 2 chlorines. I'm introducing the 2 chlorines here. They must be bonded on opposite sides of the metal complex in question. So I'm going to put my chlorine here, another chlorine here. So the fact that they're bonded on the opposite sides of the transitional metal, it forms a trans tetra aqua cobalt 2 chloride complex. Now when such happen, so the key thing you're supposed to be focusing on are the position where the atoms in question are bonded. So the fact that they are found on opposite side, and also these ones are found on this opposite side, we call that a trans geometric isomer. Now we can also go ahead and learn another thing. Even square planar complexes can exhibit this, the trans Cis geometric isomerism. Even square planar substances can show it. So how can we know that there is a trans Cis geometric isomerism in square planar substances? So in square planar complexes, square planar substances or complexes, I want to show you how. Now the example I'm going to use here is a very unique substance that is majorly found in the medicine world, a substance known as platin. Platin is the most known example that we always use. And I'm going to demonstrate that platin is just platinum molecule or a platinum metal bonded to 2 chloride atoms or 2 chlorine atoms and also 2 ammonia molecules. So it is always written as Pt Cl2 NH3 2 as our platin. And it can always show the trans and the cis isomerism in a very unique way. And let me sketch that to show you. Now the question here is going to be, the main area of focus is going to be the 2 chlorines and the ammonia molecules when distributing them. So I want to show you how this one can show a cis and trans isomerism. Trans and cis isomerism. So in the middle, I'm going to have my platinum. Then the first one is going to be ammonia here. Then on the other side, I'm going to have my chlorine. The same is going to repeat itself on the other side. Now I want to use different colors. So on one side, I'm going to have chlorine, and on the other side, I'm going to have ammonia molecule bonded. I'm going to draw another one. Now I'm going to have my platinum, and on one side I'm going to have ammonia, and on the other side I'm going to have chlorine. Use different colors so that we can see what is really happening. Then on the next side we're going to have that and that. Now on this side I'm going to use chlorine, and on the other side I'm going to use ammonia. Now I'm having two examples here. Both of them are platinum, and we can use platinum and the bonding of the molecules bonded to that platinum to show the trans and the cisness. So we said when they are found on the same side, when same atoms are found on the same side, we call that a cis isomerism. So if you look here, chlorine is found here, but the next chlorine is found on the opposite side. So when it is found on the opposite side of the metal, now it becomes, if it is found on the opposite side of the metal, it becomes a trans isomer. So this one is going to be called trans platinum. Now the same is going to, we are going to use the same concept to explain this side. When it is found on the same side of the metal complex or of the center metal, we are going to form our cis isomer. Now it is going to be a cis isomer. So this is going to be cis platinum. Now the key thing you should know here, platinum is a very important molecule or a complex that is used to manufacture anti-cancer drugs. Uses of platinum. Now the cis platinum is always used in the manufacture of anti-cancer drugs. Call them anti-cancer drugs. So through its geometry, the complex can bind with the DNA of a cancer cell. It can bind with DNA of a cancer cell, hence preventing it from replicating. Hence preventing it. Preventing it from replication. So that's a very easy way that we can use to show the geometric isomerism exhibited by different metal complexes. Thank you very much.